Okay, in this session, we consider limits at infinity. So the limit as x goes to infinity of f of x is equal to L means that as x gets arbitrarily large and positive, the value f of x becomes arbitrarily close to L. Okay, so for example, the limit as x goes to infinity of 1 over x is equal to 0. You can imagine taking larger and larger values of x, and then when you take 1 over that, you get smaller and smaller values. So that's eventually going to 0. Consider another one. Limit as x goes to infinity of 2 plus x over x. If we divide by x on both sides, we're not dividing by 0 because we're taking very large positive numbers. We would get limit as x goes to infinity of 2x plus 1 over 1. Right? Then that gives us limit as x goes to infinity of 1 plus 2x. You can use the same rules as before. The limit of the sum is the sum of the limits provided that the individual limits exist. So that's the limit as x goes to infinity of 1 plus the limit as x goes to infinity of 2 over x. That's 1 plus 0 is equal to 1. Take another one. Limit as x goes to infinity of x squared plus 1 over x squared minus 1. Factor out the largest powers of x from the numerator and the denominator. In this case, that's x squared. So you have limit as x goes to infinity of x squared times 1 plus 1 over x squared on the top. And on the bottom, you have x squared times 1 minus 1 over x squared. Because the x's are positive, there's no danger of dividing by 0. So you can cancel out the x squares. Now you have the limit as x goes to infinity of 1 plus 1 over x squared over 1 minus 1 over x squared. The limit of the quotient is quotient of the limits, provided that the individual limits exist. So that's the limit of 1 over 1 plus x squared divided by the limit of 1 minus 1 over x squared. The 1 over x squares go to 0, so that's equal to 1 over 1, which is equal to 1. Similarly, the limit as x goes to minus infinity of f of x equals L means that as x gets arbitrarily large and negative, the value f of x becomes arbitrarily close to L. Okay. We also have a squeeze theorem for limits at infinity. So, for example, supposing I have sine of x, I know that that can be bounded between minus 1 and 1. And then if I divide by x, I want to take the limit as x goes to infinity of sine of x over x. So sine of x is bounded between minus 1 and 1. If I divide by x through the inequality, I get minus 1 over x less than or equal to sine of x less than or equal to 1 plus 1 over x. Okay, so minus 1 over x is going to go to 0 as x goes to infinity. Positive 1 over x is going to go to 0 as x goes to infinity. Sine of x over x is bounded between those two values, so it should also be going to 0 by the squeeze theorem.